For the section B, question 2, question 2a, we need to use the partial fraction to change this fraction into the partial fraction. Then only we proceed to the integration. Alright, so we'll change the 2x plus 3 over x squared x minus 1 into its partial fraction, where we'll treat the x squared as our repeated linear factor, which is equivalent to a over x plus b over x squared, and x minus 1 is a linear factor, so we'll put a c on top for the factor x minus 1. Then we try to equate denominator. After you equate denominator, we just compare the numerator because both sides, the denominator are the same. Then we are trying to get the value of a, b, c either by using the elimination method or comparing the coefficient. So for this case, I will just substitute x equals to 0. When x equals to 0, the left side is equal to 3, and the right side for the term a, 0, term c also 0, okay, left the negative b. So from here, we can solve for the b equals to negative 3. Secondly, we can let x equals to 1. When x equals to 1, the term a equals to 0, term b equals to 0. Then this is a 1 square c, that will be c. And substitute the 1 into the left hand side as well. You will get 1 multiplied by 2, that is plus 3 equals to 5. Alright, then left the last one, you can substitute either any value that you like, a simple value, or by using the comparing the coefficient. If let's say you want to substitute any other value, for example, substitute x equals to 2 also can. Substitute 2 into the first term, second term, and third term at the right side. So since you already got the a, b, and c, now you can substitute inside so that you can later on solve for the a. b is a negative 3 and the c is a 5. So from here you can solve for your a. After solving, you get a equals to negative 5. Then next step, you need to rewrite your question again. That is your subject. Do not write the partial fraction, just start with the partial fraction itself. You need to have the subject first, then only you put the partial fraction at the right side. So this is your partial fraction, and now we can start to integrate. After integrate, you get this, and the final answer, it should be simplified form. This is the answer. So for this question, this is the piecewise function given. You need to find the you need to integrate from 0 to 2. From here, we can try to analyze a bit on this function. This function defined on different interval. The first is for the x is less than or equals to 1. Second is x greater than 1. When the x is less than 1, this function fx is defined by surd of x squared e to x squared. And for x greater than 1, the fx is defined by ln x squared over x. So if you would like to integrate from 0 to 2, for example, 0 is over here to 2, alright? So it involves both of the function. So we need to split this into 2. First, we integrate from 0 to 1 first for this function. Add with the plus with the integrate from 1 to 2 for the second function. And this is what I mean. Alright, this seems like can be simplified. Square root of the x squared, you will get the x, and square root of the e to x squared, you get e power of x squared. Alright, so you need to differentiate this. To integrate this, you need to I use substitution to integrate this. You let u equals to x squared. From here, you can find your du dx, that is equals to 2x. So you can see that the x dx over here, over your function over here, x dx, it can be replaced by du over 2. Okay, du over 2. So when you use substitution, don't forget to find the new limit. So when x equals to 0, what is your u? And x equals to 1, what is your u? After you find a new limit, obviously that the limit did not change. That is still 0 to 1. And x dx is replaced by du over 2, where the es squared replaced as a e power of u. Then the 1 over 2, you just can take it out. and you integrate EU with respect to U. Okay, then substitute the upper limit, e power of 1 minus e power of 0. That is the answer for the first integral. For the second integral, we're trying to simplify this ln function first by taking the 2 to the front. We got the 2 ln x over 2 over x. Alright, integrate from 1 to 2 with respect to x. Then how do you integrate ln x over x? Again, I will use substitution. Let u equals to ln x. Why? Because when you find the dy dx, you got 1 over x. Then in my function over here, I got 1 over x dx. I know that the 1 over x dx, it can be replaced by something in terms of u. So again, same thing, you need to find the new limit. Okay, so the new limit becomes a 0 to ln 2, and the 2 still will maintain as 2. The ln x will be replaced by u, and 1 over x dx will be replaced by du. So now you just integrate 2u with respect to u. So 2 can take it out, and you got the u squared over 2. Put in your limit to get marks first. Yeah, next you will get this, and simplify it, this will get 0. And finally you will get the ln 2 whole thing square. So your function, your integrate function of f(x) from 0 to 2 is equivalent to 1 over 2 e minus 1, which is the answer I plucked from the first integral, and plus the second integral answer, that is your ln 2 square. And since the question did not mention exact value, you can give them give your answer into decimal. And for exam requirement is 3 significant figure at least, that is 1.34. If the question mentioned exact value, then this is the nice one lah. You give in terms of e and the ln.